Good morning. Thank you for joining us. Like Anthony said, my name is Bill Limpisathian. I am a doctoral student at the University of Oregon and also a cartographer at the infographics lab within the department. So today I'm going to chat to you a bit about my ongoing dissertation research that looks at basically the intersection of neuroscience and cartographic design with a special emphasis on visual contrast and the role it plays in map cognition and the map cognition process. So I know this topic can be a little heavy even for myself, admittedly. I am a trained cartographer, not so much a neuroscientist. So I'm going to try my best to keep it as light and interesting as possible for all of our sakes. So if you were at NACIS last year and just happened to come to my talk, you might have remembered me talking about how I wanted to pivot my research away from more behavioral perception research using user studies to something that integrates more neurogeographic, neuroscience, cognition into the process. And that basically stemmed from my own master thesis research with Cindy at Penn State, trying to find the most optimal configuration of visual contrast design for maps. And I found curious patterns that I couldn't really explain away with behavioral testing. So that sort of led me down the rabbit hole of what if I use more neuroscience, cognition, understanding and methods to help sort of give a better understanding and insight into what is going on inside the brain that helps explain all of this. So that's sort of what how I ended up doing quote unquote neuroscience. And then over the course of last year, I've basically been learning, again, quote unquote, learn neuroimaging methodologies and conducting lit review of comparable topics from psychology and neuroscience. And basically what I found so far is very distressing, at least for me. It's that essentially stuff like Gestalt, which is like a huge law that underpins so much of cartographic research, has been flipped on its head and been reframed as like a loose principle, a dated loose principle that hasn't really been empirically tested on like a human perception cognition basis. And that neuropsychologists have very limited interest at all in visual contrast, which is like my whole thing. So I was like, come on guys, how am I supposed to do research here if you guys don't care about it? Warsaw, I found that the more I dug, the worse it got. I found out that generally it's just accepted that visual contrast and Gestalt figure grounds and related proxies are considered pre-attentional perception. So what essentially that means is that they say and they accept that it's important for us seeing the map or the thing in front of us, but once the brain sees that, the design aspect is stripped away, and that your brain will figure out what it figures out on its own from the spatial information or the information underneath. So it's only for seeing, not for understanding, not for thinking, not for paying attention, not anything that we've been saying. So I'm like, WTF? Like what the figure ground? Yes, exactly. How can it be that something we cartographers say is super important be so clearly dismissed and disregarded? And what is this, like what's gonna happen to my grad career if this is what I've been focusing on all this time? And also, like, how is it possible for me to somehow hopefully resolve this clearly conflicting and opposing notions, or have we just been wrong this whole time and they're right and yada yada whatever? Hopefully not. So okay, now that I've scared you a little bit or scared myself, I'm gonna take a step back and basically sort of talk about some of the related theories and principles to my research. I know I'm in a room of cartographers, so I'm not going to go deep into what is cartographic visual contrast, but essentially we use it to guide user attention, and it's derived from Gestalt psychology. Plenty of people, including people in this room, have talked about it at past NACISs and study it so much. But if we look over in neuroscience, visual contrast isn't really studied. Like I said, the closest proxy that has been studied is through Gestalt figure ground and partially light detection and sensitivity. So for the purpose of this talk, I'm gonna basically use figure ground as a proxy analogous of visual contrast, just because that's where the literature is. But figure ground describes the perceptual process relationship between what you perceive as the foreground and what is perceived in the background. Whatever is perceived as the figure is processed in a higher cognitive and perceptual level from what is against the ground. Okay, now we're gonna get a little bit into the brain stuff, but I'm gonna try to make this as simple and clear as possible. So like hold tight and we'll get through this together. Yeah, okay, so where does figure ground happen in the brain? So there's a few research that has looked into this. So essentially they say that it is part of this visual stream or visual system process where it is happens in a hierarchy where basic parts of what you see are processed by lower level that feeds into subsequently higher level and more complex functions. If you look at on the diagram to the right, basically where they say figure ground and visual contrast is happening is in the blue region, which is your V1 through V4, which is your visual cortex, which is in the back of your brain. Essentially, here's the brain. You can see the eyes, the giant blue fake eyes. The visual information you see gets sent to your occipital lobe, which is where your primary visual cortex is, and then gets processed by subsequent streams and functions. Essentially, what we know about figure ground comes from two main research in the 90s, one by Lamy, who basically studied monkey brains. And from that, he was able to identify that there were these specialized neurons in the back of your brain that fire selectively for whatever is conceived, whatever is perceived as part of the figure, and does not fire for whatever is perceived as part of the ground. And then there's a similar research on a stroke patient from 1992 by a team led by Driver. And basically this old dude had a stroke and he lost higher level attentional function in his brain. So it's called hemispherical visual neglect. So he couldn't pay attention to things happening in his left visual field because of damage to the right side of his brain. But his visual cortex was unaffected, so therefore he was still able to see in the typical sense, like you still see the thing, but you can't attend to it using higher level mental processes. So you can't imagine something after you've seen it. So if I see this water bottle and I look away, I lost all sense of that water bottle. Something like that. Okay, so that basically was, so they used that deficit in order to test whether you can still perceive this figure ground effect even with this brain damage. And they found that yes, you can still process figure ground and you can still see it even though you're not subsequently able to perceive it later. I'm trying to simplify this for you guys. If you want me to explain more in depth, come talk to me afterwards. I do have a limited set of time, but I'm trying my best. So, okay, moving on. So this figure is basically, I found out, is what neuroscientists likes to put up when you tell them you want to study the visual stream. It's sort of like a subway map, or at least I see it as like a city subway map. So essentially, it's just a conceptualization of how you process visual information from incoming from your eye at the bottom to higher level places in your brain up top. And essentially, essentially a translation of what I've been saying or what they have been saying is that visual contrast and figure ground only happens in this. So barely a quarter of this process. So again, I still, am completely stumped by how is it possible that they are able to justify this limited conceptualization where say that attention cognition conceptualization does not matter for visual contrast. So it just leaves me scratching my head, like, what is going on? How can it be? Again, like I said, cartographic literature, all of the textbooks I've read in my, 7 years of cartographic education have been saying how important all of this is. How is it possible that everything I know can be disregarded? And more importantly, how do I resolve this and keep going with what I want to do? To be honest, this has been what's keeping me up at night, many nights of like, how do I proceed from here? And while at this semi-early stage, I can't really say whether I'll figure out this or whether I'll be able to say whether we're right or they're wrong, or maybe they're right. I promise I'm doing my best with my research, maybe dig myself out of this rabbit hole. Okay, so what is it that I think is happening? What is my hypothesis here? So essentially, I don't necessarily think that neuroscientists are wrong per se, but then I don't think we're wrong either in how we conceptualize visual contrast or why we think it's so important. Essentially, the issue at hand for me is basically how the two fields understand and conceptualize visual contrast itself and how they approach and study this essential topic. Like I said, a neuroscientist believes in this or is bound by this hierarchical structure of how the visual stream works. So essentially, I think they're very much limiting themselves to how they're conceptualizing visual contrast, that it has to be part of this distinct process, subsequent process that feeds into each other in order for it to fit with their overall model, instead of how we might conceptualize it as a more holistic, more multi-pronged approach, where it's not A feeding into B, it's happening all at once, and it's relevant and important for all different stages of this map cognition process. And yes, while I showed that neuroscience does have empirical research that says, yes, visual contrast occurs during a lower level perceptual process, I made the realization later that none of that research actually explicitly states or dismiss or dissociate that process itself from any higher level cognition process. It's just that they have not studied it because their understanding of it says that if it's already processed at a lower level, it can't be relevant for subsequent part because then it doesn't work with it, with what they believe in. And then, of course, cartographers, geographers, we love to say spatial is special. And then even research from my own lab and a lot of map cognition and spatial cognition research I've read doing this kind of stuff. We know that the human brain process spatial information, especially maps, distinctly and differently from, say, a normal shape without geographic information. Maybe it's just the fact that neuroscientists have been testing this using non-spatial stimuli. Therefore, we don't know how much this result actually applies to a field like cartography or geography, and that potentially they just need to do more research and extend this research using a more distinct array of stimuli, including maps. Okay, so what am I doing about my problems? Okay, so I am fortunate enough to be in a lab that is interested in exactly these types of questions and wants to know how our brain understands space and how our brain reads maps. So essentially, I'm gonna sort of cheat little and hope to take a lot of these established understanding by amazing professors and colleagues and in a sense integrate a design layer on top of this. I plan on essentially, this is your brain on maps. So basically take these existing research. I'm not going to say we know completely everything about how your brain processes maps, because we don't, because the brain is complex and it's a whole thing. But essentially taking our existing research as a baseline of sorts because we sort of do understand what is happening in your head as part of this map cognition process, and then overlaying this cartographic aspect or design aspect to see if that changes anything that's lighting up in your head. So essentially throwing a bunch of these contrast configurations and design variations and seeing if, compared to this baseline activation of map cognition, if we change the hue, if we change the contrast level, if we change some of these design aspects, does that baseline changes as a proxy to see if you're still understanding the same spatial information of underlying that map in the same sense and in the same way. And that's essentially what I'm really excited about, at the prospect of maybe, hopefully, fingers crossed, potentially cracking this theoretical egg. It's still early in the process. I need a lot of money to do fMRI research. They don't tell you that going in. Yeah, so stay tuned as I continue doing that. Okay, to sum it up, what are my goals, hopes, and dreams? I said this basically last year, but I'm going to just say it again. But I hope to be able to confirm what us cartographers know, that visual contrast is super important for map cognition. And maybe along the way, I'll be able to convince just a few neuroscientists to maybe reconceptualize or look at visual contrast in new light and not be so dismissive about it. But then at the same time, I'm a pragmatist, so I have to admit that I could be wrong, that we could all be wrong. Maybe at the end of this journey, I'll find out that visual contrast and how we conceptualize it isn't as relevant as it could be. And maybe that would just lead to a re-examination of how we do understand and how we do conceptualize visual contrast and figure ground theory in cartographic literature. But whatever I do find, I am excited to share with you at a future NACIS. And that is it. Thank you. Yeah. Right.